Hello everyone, welcome to Machine Learning with Tensorflow. In this tutorial, we will learn how to code in Tensorflow. Before that, we have to know a bit about neural network. In neural network, we must have a data set for which we know the input as well as the corresponding output. We will divide the data set in two parts, training and validation. Sometimes validation is referred as test dataset, but test is not the correct word for that purpose. With the training set, we train the weights of the network, and with the validation set, we determine the accuracy of the training. Let's have a look at the network again. In the network, we have input X, and that input goes through the input weights W, and that creates the hidden layer output A, that goes through the activation function and creates D, and D goes through output layer weights V, and that creates the output Y. After creating the output, we take the difference between the created output and the original output. That gives us the error. Then we backpropagate this error through these layers and we update the weights. After each update, the weight gets improved. And when we give a lot of input and complete a lot of backpropagation and update the weights, at the end the weights fit the desired nature of the relation between input and output. An important thing to note that the input weight here is nothing but a matrix, and the output weight here is nothing but a vector. In this example, we will try to fit this nonlinear curve which has an expression y equals 2x squared plus 1 in this network. So what will we do? That we'll pass each input x and y through the network, and we will backpropagate it, and we will update the weights. One interesting thing you can note that this is a nonlinear function, and here we are multiplying this input to the input weights, which is a linear operation. So how can we achieve a nonlinear curve using a linear network? We cannot unless we use this nonlinear activation function. These activation functions create the nonlinearity in the relation between x and y. So how the training process works? Let's have a look at an example. If we build a neural network and we try to train, we see that in the beginning we start with random weights, then the fitness is completely different. Over time, the weights gets improved and the network learns how to behave like the desired function, that is y equals 2x squared plus 1. Now we will see how to code this in TensorFlow. Let's go to Jupyter Notebook. I have already written the code. At first you have to import TensorFlow and NumPy. Let's import it and run that cell. In the second cell, we are defining the number of hidden neurons to be 2. We are defining the epoch number to be 4200. We are defining the input xt as a linearly spaced numbers in between -1 and 1. We will take 21 points. We will initializing yt with zeros, and after that we are creating yt for each value of x. Then we are concatenating a bias of 1s with the input value. If you print this concatenated matrix, you will get something like this. That means we have 1 and -1 as the first input set, 1 and minus 0.9 as the second input set, 1 and minus 0.8 as the third input set. Now let's come to the part of TensorFlow. To give input and output values, we will use tensors of type placeholder. What is a tensor? Tensor is nothing but a matrix with n dimension. What is a placeholder? Placeholders are used for either input or output. Then we will initialize our input and output weights as TensorFlow variables. What are the variables? The variables are those which will change their value during the training process. We are initializing them as random uniform, and then we are scaling and shifting it to get better performance. After creating the input and output weights, we will multiply the input with the input weights to create the hidden layer output, and then we'll pass the hidden layer output through the activation function. Then we'll multiply the output of the activation function with the output weights to get the output. This is the calculated output. Then we will calculate the difference between the actual output and the estimated output. Then we will take the square of that loss and we will take the mean of that to form the cost function. After that, we will define an optimizer. In this case, we have used gradient descent optimizer with learning rate 0.1, and this optimizer will minimize the cost function that is defined here. After building the network, we will create a TensorFlow session as sys. Then we will initialize the global variables. Then we will run the training process for the number of epochs defined above. For each epoch, we tell the compiler to run the optimizer for this cost function, where the inputs are given with this parameter feedDict. X is the placeholder and xs is the input, y is the placeholder for the output, and yt is the actual output. And for each epoch, we will print the epoch number and the corresponding cost. At the end of the training, we will have a look at the input and output weights. So let's run this. If you note that with the increase of the epochs, the cost gets reduced. That means our training process is converging. At the end, we will see the input layer weights and the output layer weights. If we check the input and output layer weights with the training process done in MATLAB, we see that they are quite close. It's around minus 2.13, 2.94, minus 2.13, minus 2.94, and in MATLAB we have got minus 2.26, 2.84, minus 2.04, and minus 2.52. For the output layer weight, here we have got around 4.4 and 4.5, while here we have got around 3.8. It is important to remember that in the training process, you are not going to get the same result every time you run, because you are initializing your weights randomly each time. So that's it for today. Thanks for watching.